I laid out all my stuff, or like maybe a quarter of it, that I like to sell. A guy named Jim has said he wanted to buy this big motor here and the other big motor like it. And then he's saying, hey, you know, what other stuff? He's taught electronics in the military for a long time, and now he's retired and wants to do a bunch of stuff. So anyways, I told him I'd do these solid state relays I have. And these here are 20 amp 480 volt DC type solid state relays. So the gates are totally isolated from the load side. And try and find some of these. You won't be able to find them. I got these quite a while back. So these are 20 amp ones. They're made by Gold, a Chinese company, of course. And then I have I have 5 40 amp ones. These are a bit slower in switching than these, but they're twice the amperage you can do. When you hook these up, if you ever accidentally switch the trigger side leads from positive into negative or do something stupid, you'll blow them up just instantly. So the ones I blew up, I would go inside, dig out that MOSFET that blew. It's usually the MOSFET that blows, not the electronics for the switching the gate. Almost always the MOSFET will blow. So anyway, so I paralleled 3 MOSFETs, and so now I have working solid state relays again. And for peak coil shorting, you want to have paralleled MOSFETs to get that impedance down really low, and you want them unidirectional. I mean bidirectional, where the gates of the MOSFETs and the source connect. So it's like the gates of this side and the gates of this side connect, the source lead of this side connects, the source leads of this side connects, and the switching happens between the drain of these paralleled MOSFETs and the drain of these paralleled MOSFETs. So I made these for peak coil shorting. 1, 2, 3, 4, 5, and then this one too. 6 of those. These MOSFETs on here, Jim was also asking about what's a good MOSFET. So all of these are IRF P460s. All of these. And I bought zillions of those, and they're rated at 500 volts and 20 amps. So when you do 4 of them, it's rated at 80 amps. But because they're bidirectional, they're sort of in series. So this is like 40 amp, 500 volts. And the reason for bidirectional is it switches AC. And so peak coil shorting is kind of an AC signal that you're shorting out. I also have these little relays, solid state. They're like 2 amp rated, 200 volt. I never use these much. And I have some of these too, which are about the same. And what else do I have? So I'll show you some other things I got. That PM, what's that guy's name? PM Hydrid. He has a lot of videos. He makes really nice stuff. Motors, really well built. And generators. PM4G Hybrid or something like that. He's on YouTube. And he had this thing where this company makes this for him. This cost me $85, this housing. And then it has these neodymium magnets here in those slots, and then smaller ones here. And it's a regular kind of DC motor in there. I use the same one that he recommends in his videos. And he was showing it going like at 20,000 RPM. It's like ridiculous. Just ridiculous when you put these magnets on the housing like this. So I have a magnetic clutch here. So you can take another one with 4 magnets and have it latch to it and then drive generators or what you want to do. So anyways, this cost me, I don't know, 160 bucks. So I'd sell this for $85. No, I don't know. I'm going to say 150 because these magnets were expensive for the magnets. But I'll take offers. And so I have these, I went on a Rene charger binge. Here's these nice diodes that I always use. And big core, lots of winds. And then I had nice brass fittings for the power supply input and the output. And the idea, I made them in these jars so you can fill them with oil if it gets hot. But it never got hot, so they're just what they're in. So I have 2 of these left. I'd sell them for $75 each. And for the power supply, you get like a computer power supply. You know, you can get them at thrift stores, not much money. 19 volts, you want 19 volt ones, 20 volt ones. And that's the power supply for these. And then you plug the other one, I have these go to the battery. So in my electric car, I would use these to charge the battery up. And it kind of works like a jewel thief. It's charging the battery with kind of resonant spikes plus a regular over voltage. It shoots through first with like 19 volts into a 12 volt battery, and then it here's the other one, and then it has a kickback, and then the recoil flyback also goes in to charge the batteries. You can look up the Rene charger on YouTube, RENA. You can see lots of people have made them. And everybody says they work great, and they work great for me. And so this is my version, kind of heavy duty version. So I'm going to move on, try to get this going here. Now, I would be willing to sell these. These, you can see I went on a binge of stator plates made of like 1-inch thick plywood. And all epoxied in. So these have the nanocrystalline cores. Oh wait, I'm sorry. These are just air cores. These are just air cores. Air cores, air cores. And so there's 8 on each. When you have air cores, you can do peak coil shorting really good because there's no cores to interfere with the hyper ringing. And so this one would probably have a rotor of 2-inch or 1 1/4 inch magnets flipping around it. Whatever you want to do, it's 8 and 8 air cores. Pretty thick winds, 18 gauge. So this is, I would recommend all in series, kind of raise the impedance. But you could go parallel and just run it on high amps and low voltage, whatever. So here's this one. Here's the other side. This is the side that goes against the magnets. It's nice and flat. This side, the other side, is where you have all the hookup with the wires. Here's the other side, nice and flat. So the rotor would go between here and here. Okay, so there's that one. Here's this one. This is pretty cool. This is my Orbo motor. 1, 2, 3, 4, 5, 6, 8. You can see the toroid motor coils inside a whole bunch of wraps of, and these would be induced generator coils. Whoops, sorry about that. And so this side's flat. This would go against the rotor, disc rotor of neodymiums. The other side's where you have the hookup, and they're raised a little bit up from the wood. You can see I really used a lot of epoxy on them. Really holds them in good doing them with this plywood. See how much plywood there is? I kind of like it like this. So here's the other one. Again, toroids inside the generator coils. So there's the project if anybody wants to work on it. So now we get over here, and now these are nanocrystalline cores in here, 5 of them. Same with over here. This is the flat side that would go against the rotor. This is the flat side. The back side, it sticks out, and this is where all the wiring is. There are those, it's like Met glass. But that guy in Calgary, his name is Journey. I remember his name now. He had a really cool Orbo motor, and he figured out for like whipping magnets past cores what's the best thing to use. Did all his calculations, and these were them, and so we ordered a whole bunch of them. So I made so there's this one with 5. Here is this is air cores. It's just plastic inside there, the white. And I have 4 of these identical. And these are meant to have 4 stators in a row with 3 rotors. Air cores, 18 gauge wire. And my videos with the rotoverters spinning the AC flat disc rotor, I used 2 of these. And then I made 2 identical ones. So this would be for a 4-rotor motor, I mean a 3-rotor motor with 4 stators. That's what this is about, these 4. So there's 1, 2, 3, 4. 4 stator plate assemblies I'd be willing to sell. I don't know what price I would sell them for, but it wouldn't be that much. Whatever that much is. I can't really think price right now for those, but I don't know. I'd take $50 a plate. 50, 50, 50, 50, 50, 50. I don't know, I'll take offers. So I got 2 of these. Never used them. I'd sell both for 150 probably. You know, these, everybody knows what these are. Out of washing machines. Fisher and Paykel, some other brands make them. They, the winds in these are a little bit thinner than the winds in these. And rotor diameter is a little bit bigger here than here, it looks like. A little bit. So if you want to count the cores and coils, you can freeze that. And here, can't really see behind there. So I'd sell these 2. I'm never going to use those. I'd rather make my own like that. Big cutting disc I showed about 2 videos ago with the magnets pinching themselves, 28 magnets pinching themselves on both sides. I'd rather have something like that than one of these. You know what I don't like about these? Is only one side of the coils doing work against the magnets. There's nothing happening on this side. You get twice the power if you had a rotor inside with magnets. But you can't do it with this radial design really. But the flat disc design, you can always get magnets on both sides of the coils. Also, I'm not a big fan of these ceramic magnets. I think you should have the most powerful magnets possible always. Let the magnets do the work, Bill Muller would say. But some people get really good results with these, and they're already assembled and machine tolerance and all that. So there's those 2. Here's, I haven't shown these yet. This has got a 3D printed little timing disc, and it's a optic. It's off, and then when that little hole comes by, it lets the little signal, the optic signal, pass through and switch on the MOSFET. And these are really nice coils here. When I was at the farm, they have like, I don't know, really thin wire. I stretched them between 2 trees like 100 yards apart, and I made them not sure how five or how many, I think it was like supposed to be like Litz wire, like 8 wires, very thin. I made a whole bunch of these coils. It took a long time. I think that's what they are. It says 2.4 ohms there, so that's not actually that. This is something else. But I have those mounted there. And how many magnets? There's only 4 magnets here. So this is a little test motor I made for the optic triggering. And then I have another one. This is an Orbo motor. It's a little test motor. This has 5 magnets in it. And it's also optic, a little bit more pulse width because I made the holes the signal passes through a little bit wider. And here's the interior toroid for Orbo design motoring or whatever, and then the generator coils on the outside. So this was a test motor for the Orbo design with the generator coils surrounding the toroid. And there's a little one of my little circuits with a MOSFET 4421 driver chip and all that. Little same thing here. So I have 2 bins like this full of AC oil-filled caps of all sizes. I use these for rotoverters. I have so many of these you wouldn't believe it. I'd be willing to sell what I got, what you need for these too. I have so many. I don't have them here right now. Also, I have these big caps I'd be willing to sell. 5 of them. They have 500,000 UF, so they're each are half a farad. I bought these off eBay. I used to have a lot more. I might have a lot more, but these are all I can find now. And I bought these from some sort of prison. Like the city I bought them from had a big prison camp. I have a feeling these were used for electric chairs. This is just my theory, because they electrocute people with DC. AC won't kill them. But that's just, just making that up. So, here we go. This is all this stuff. If anybody wants it, make me an offer. I can't refuse. I'm making this especially for Jim, actually, because I told him about these solid-state relays. Maybe he wants them. Also, he was asking about what is a good MOSFET. So I recommend the IRF P460, 500 volt, 20 amp. But look at all these other MOSFETs you can get, which I have quite a bit of, but not so many as these P460s. Look at the 42NG5MS, 650 volt, 35 amp. You can get those. Those work. This is N channel. You put the MOSFET next to the ground. This one's N channel. You put the MOSFET next to the ground. This one's P channel, IXTH20P50P. This is P channel. You put the MOSFET next to the positive, feeding the coil. So it's before the coil with a P channel. It's after the coil with an N channel. For transistors, like in my Jewel Thief Renee charger thing, there's that 3055, I think it is, that everybody uses, like in a Bedini circuit. Well, this one's, I don't know why more people, this one's really good. See, 3552 transistors. They go to like 1,000 volts, 12 amps, and they go really fast frequency. So if I was to make a Bedini circuit, I would use these, where it has a trigger wind within the coil. And here's I never use these, I don't know, but I also have a bunch of these. G3ON60B3, I think this is what Ismail Viso likes to use. They're 30 amp, 600 volt, but I don't use IGBTs, I just use straight MOSFETs. So, I guess this is getting to be an old video, 25 minutes already. Sorry, Charlie. So let's see. This one, okay, if I sell this, I don't have any timing stuff on this one. Also, I want to say they are trifilar wines. I checked that. Yeah, they're trifilar. And the other one's bifilar. So it's two parallel wines in the other one like this, and it's three parallel wines in this one. And just a minute, I'm going to walk back into here. So here's my other one, using it as a lamp base. So on this side, I see I got 4 of these magnets here. So this is like a magnetic clutch, so you make the same thing and you can stick generators on it and stuff. Oh, I'm sorry, these are also trifilar wines. Just checking, I can tell they're trifilar. So there's 3 parallel wires. It's about 22 gauge wire. These have black sand cores. And I do have a timing circuit on this with Hall effects here, stuff. But it's not working right now. I'm kind of selling just the chassis. You have to do this yourself, make how you want it to be with Hall effects. But you can run these on straight AC, which is actually the purpose of them, is making AC motors with neodymium magnets in them, really strong ones, flat disc style. So I'm going to conclude this video. Sorry it was so long. Thanks for watching.